Hi guys, welcome back to another lesson in probability. In this lesson we are going to look at tree diagrams and using tree diagrams to represent data and also as a way of calculating probability of an outcome occurring. So first let's look at how we use tree diagrams. So we're going to use the tree diagram on the right to answer some questions. So the first one is how many possible outcomes are there in total? So if we go through, well this one here, if we follow our chain of our tree, so we flip a coin and we either have an option of heads or tails initially. Okay, so for our first outcome, we've gone heads, so flipping it 4 times. The first time we get heads, the second time heads, third time heads, fourth time heads. So we get heads, 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 heads. This next one we get heads, 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 and then a tail. This one here we get heads, heads, tail, heads. This one is heads, heads, tail, tail. And so on until we get all of our outcomes listed. So this is a really good way of showing like the different possible outcomes that we could possibly get, the different combinations. Okay, and it can work for when you have a variety of or a large number of different possible outcomes, and we're going to look at that in the next example, or not the next one, the one after that. So in total, how many possible outcomes are there? Well, there's 16, so that's all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now it's important to notice as well, 16 is the number of final outcomes here as well, the number of final branches. So find the probability of flipping at least one heads. So what we're going to do first is circle or put a box around all the ones where we get at least one head. So we have to have one head. So the way I did this was I looked at which ones didn't have heads at all. Okay, and there's only one option that had absolutely no heads, and that's this final one. So if I'm looking for how many have heads, well that's the other 15. So I get 15 out of 16, so the probability of at least one head equals 15 out of 16, which gives us a probability of 0.94. If we look again at least 2 heads, I want you to pause that, go and calculate the probability of getting at least 2 heads and then come back. Okay, so if we look at the possibility of getting at least, or the probability, sorry, of getting at least 2 heads, we have 11 possible outcomes with 2 or more heads as an option. So we have 11 out of 16, which gives us a decimal of 0.688. Now the next and final one is getting exactly 3 heads. So if we indicate the outcomes that have at exactly 3 heads, so that's no more than 3 and no less than 3, well we have 4 possible outcomes, which gives us a fraction or a probability of, I did change that to 4 out of 16, but that's okay, we'll just change that quickly now. 4 out of 16. Which gives us a decimal or a probability of 0.25. So let's look at drawing tree diagrams and how we go about drawing them. Now you could do what I'm going to do, which is have little symbols, or you also could use letters. So a young couple, Tim and Sarah, begin to talk about starting a family. Tim decides he would like 3 children, 2 boys and a girl in any order. What is the probability of them having 2 boys and a girl? So we're going to use a tree diagram to help us answer this. Okay, so I'm using symbols. I'm going to use blue and a pink baby, but you could also just write B or G, so for boy or girl. So their first child is either going to be a male or a female child. Then if we go off our male, we're going to have, if we have a second child, so we had a male the first time and we're going for our second child, the possible outcomes are again either a boy or a girl. Now if we go, they've had a boy for their first child, a boy for their second child. Now they're going for their third child. again, it's going to be either a boy or a girl. And we keep doing this until we've got our 3 rows all filled out. So here we have our boy and our girl. Then back over to here we have boy and girl, and boy and girl. So now I'm going to follow each branch of our tree diagram and write the possible outcomes down here. So the first outcome could be having a boy, then a boy, then a boy. So I'm going to write B, B, B for boy, boy, boy. The second one is boy, boy, girl. The third one is boy, girl, boy. And then boy, girl, girl. Then over here we have girl, boy, boy. Then we have girl, boy, girl. Then girl, girl, boy. And girl, girl, girl. So what are the probabilities of having 2 boys and a girl? So let's go through and find all of the outcomes that are 2 boys and a girl. So the total, we'll start with the total number of outcomes, which is out of 8 possible outcomes. So the probability of 2 boys and 1 girl, so there's 1 outcome, 2 outcomes, 3 outcomes. So there's 3 possible outcomes out of the 8. So the probability of getting 2 boys and 1 girl is 0.375. So let's look at another example. So this is when there's multiple possibilities. So if we go back to our boy and girl, each time there was only 2 possible outcomes. It was either going to be a boy or a girl. But what if there are multiple outcomes that we could obtain? So Nick wakes up to find that his power is out. He decides that he is going to get dressed in the dark. He knows he has a pile of clothes at the end of his bed, so he just grabs an item at random. In the pile there is a yellow, green and orange shirt, blue and grey pants, and orange, green and red shoes. What is the probability that he is wearing a green shirt and red shoes? So we're going to draw a tree diagram to represent this. Now because there's multiple items and we're talking about colours and the colours are occurring within different items, like we have a green shirt and green shoes, we can get a little bit confusing. So using symbols can be quite helpful. So we have our male, what did I call him again? Nick. So we have Nick here. Now, the first thing he grabs is a shirt. So there are 3 possible outcomes. It's either going to be yellow, green or orange. So say he was to grab a yellow shirt and then he grabs some pants. From that, it's either going to be a grey pair or a blue pair of pants. Now say he grabs the grey pair of pants. There are 3 options for our shoes. They're either going to be orange, green or red. Now we do the same for each branch. So then we go back to our pants and we do our 3 shoes. Our green shirts, we do our 2 jeans or 2 pants, our 3 shoes, and then our orange shirt is 2 pants and 3 shoes. Now you might need to pause this so that you can add these diagrams into your notes. So let's put our combinations together. How many different outcomes? So yellow shirt, grey pants, there are 3 outcomes because you could have 3 different pairs of shoes. Same with the blue, 3 outcomes. And we just keep going till we fill all of our outcomes. So the question was, first the total number of outcomes. So 3, 6, 9, 12, 15, 18 possible outcomes. So what is the probability of getting a green shirt and red pants? So green shirt means we're just looking at these outcomes here. And the outcomes that are green shirt and red shoes are these 2. Now it doesn't say what colour pants, so it doesn't matter. So the probability is 2 out of 18 or 1 out of 9, which gives us a decimal of 0.11. Now let's do one final example using probabilities related to uneven or uneven weighted outcomes. So here we have 7 red and 9 blue. So each time you select a marble, the probability of selecting a 7 is lower than the probability of getting a 9 because there's more, not 9. What am I talking about? The probability of selecting a red marble is less than the probability of selecting a blue marble because there's less red marbles than blue. So Meg has a bag of marbles that has 7 red and 9 blue marbles. She selects 2 marbles, replacing the first one, so putting it back into the jar before choosing the second one. And that's important because it means that the probability stays the same each time. So let's draw a diagram to represent this situation. So our first pick is either going to be a red or a blue marble. If we selected a red marble, we have the probability of 7 out of 16. If it was a blue one, the probability is 9 out of 16. Now we're going to select again either a red or a blue. So again, the probability is 7/16 for selecting a red, and the probability of a blue is 9/16. Now these don't change because the fact that we kept replacing or putting back that marble first. If we took the marble out and we kept it out, it would drop the number of possible outcomes and would change the probability. So it's important to make sure you read the question and what is actually happening. Then if we go back down to our blue marble, again we have red or blue, which is 7/16 and 9/16. So let's use our diagram over here to find out what the probability of getting a red then a blue is. And the way we do this is the probability of red then blue equals 7/16 times 9/16 because we went red and then blue. So what we end up with is 63 over 256. And if we were to put that into our calculator, we end up with 0.246. Then we go over here and we'll look again, what is the probability of drawing 2 blues, so obtaining 2 blues? So that's this row here, or this branch here should I say. So the probability is 9/16 times 9/16, which gives us a probability of 81 out of 256. Which gives us a probability of 0.316. Now, hopefully that makes sense. It will come more when you do some questions, but again, if you are confused, please make sure you ask. Maybe you'd like another example, whatever it is you need, please make sure you do ask. Thanks guys, I'll see you in the next video.